Hello everybody, welcome to 2.5. What we're going to do today is we're going to learn how to find complex zeros given a complex zero, and we're going to learn how to approach finding all real zeros of a polynomial. To begin, we're going to talk about how complex, goodness gracious, complex zeros, occur in conjugate pairs. So what we know is that if A plus BI is a zero, then A minus BI must also be a zero. And what we can also say from there is when we're given find all zeros of f of x equals x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. And we're given that 1 plus 3i is a 0 of f. What I was saying is what we can use from this statement is that we also know a factor if we know a zero. So that being said, if we were given the statement instead that, let's say, 3 is a zero, we know we can use this information to create a factor. And the factor we would create would be x minus 3. We're going to use that same strategy, and we're going to call this creating a factor. We're going to say that we know we have a factor of x minus this 0, x minus 1 plus 3i. We also know that the complex conjugate of this complex number is 1 minus 3i. And because of that, we know we also have another factor of x minus 1 minus 3i. And what we can do now is we can use this information to create the piece of the polynomial that we have accounted for with these zeros. We can, I'm not going to say FOIL because we're not going to FOIL. I'm going to say we're going to multiply our zeros. Our factors, let's use the right term. We're going to multiply our factors, these two factors, x minus 1 plus 3i times x minus 1 minus 3i. And instead of doing a lot of unnecessary work, what I'm going to do here is I'm going to rewrite this so it makes a little bit more sense. I'm going to say x minus 1 in parentheses, and then I'm going to say plus 3i. And then I'm going to say x minus 1, again in parentheses, and I'm going to say minus 3i. Because of the associative property of addition, we're allowed to do that. And what we can use now is an identity from your cheat sheet, if you remember, of when I have an x minus a b and I have an x plus a b, what I actually have is an x squared minus a b squared. My x, in this case, is x minus 1, so I have x minus 1 squared, and then I have minus a 3i squared. And I should have that in parentheses. When I start to simplify here, what I'm going to get first is another identity here. And the identity here is that x squared minus the 2x times 1, or just minus 2x, and then plus 1. That's what x minus 1 squared comes out to be. And then I have minus 3i squared. And so what I'm going to have is minus 9i squared, or x squared minus 2x plus 1 times, with negative 9 times negative 1. I simplify some more, going to write it over here to the side. X squared minus 2x plus 1 plus 10 and then from that, oh my goodness, I meant to say 9 here, plus 9, and then I get x squared minus 2x plus 10. That is the polynomial that could be factored out to be 1 minus 3i, 1 plus 3i. But what I need to do with this now is I need to divide it out of my original polynomial. And that's what our next step is going to be written as. Since my original polynomial was, we're going to write the step out, divide out from original polynomial. Since my original polynomial was x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60, and I'm dividing x squared minus 2x plus 10. That's what my division is going to look like. I know that x squared times x squared gets me x to the 4th. I multiply back, I get x to the 4th minus 2x cubed plus 10x squared. I change all of my signs, and I get negative x cubed minus 4x squared plus 2x. That guy comes down. I know x squared times negative x is going to be negative x cubed. And then I get plus 2x squared. And then I get minus 10x. And then from here, I can change my signs. Those go away. I get negative 6x squared, and I get plus 12x, and then negative 60 comes down. And now x times negative 6 is going to get me negative 6x squared. It's going to get me positive 12x, and it's going to get me negative 60. I change all of my signs, and I see that I'm going to get 0. And that's helpful because now what I have is another factor of this polynomial. I know that x squared minus 2x plus 10 was a factor, and now I also know that x squared minus x minus 6 is a factor. I know that this can be factored already as that x minus 1 plus 3i and x minus 1 minus 3i. And this polynomial I know I can factor as x minus 3, x plus 2. And so what I have found now are all of my zeros. I know I have a 0 at the two complex numbers already. I know that I have a 0 at 1 plus 3i, 1 minus 3i, the complex and its conjugate. And now I know I have a 0 at 3, and I also have a 0 at negative 2. So that's one way to find all real zeros. Another way to find all of your zeros is to use the rational zero theorem. And we have already done this before, but we'll go over another example of doing that again. So, say for example, you're given the function, let's make sure you can see it, there we go. The function f of x equals 2x cubed plus 3x squared minus 8x plus 3. And you're asked to find the rational zeros? Well, we know from the leading coefficient and the constant that we're going to look at factors of 3 over factors of 2, right? Factors of the constant over factors of the leading coefficient. And when we do that, we're going to get plus or minus 1 plus or minus 3 over plus or minus 1 plus or minus 2. And from here, what we can grasp is that we're going to get the factors of plus or minus 1, plus or minus 1/2, plus or minus 3, and plus or minus 3/2. And what we can do next, before we start plugging everything in, is we can graph this in our calculator in order to understand which one of these might be useful to plug in, instead of plugging in 2, 4, 6, 8, 10, or just 8 of these zeros. That would be a lot to do. So again, instead of having to plug in 8 different things, a better idea is to take a look at your graph of that polynomial, and then determine where those zeros might be, and then use an approximation of what you might actually have to use the synthetic division for. So, if we take a look at our calculator, we can type in our original polynomial, which is 2x cubed plus 3x squared minus 8x plus 3. And if I graph that, I'm in Zoom Fit right now, and that's actually kind of useful because now I can see the whole thing of what it's doing. I would like to look a little bit closer though, so I'm going to press Zoom. I'm going to press Zoom Standard. Okay, I'm going to change it, or you know what, no, I think I'm good to go because right here I can see about where my zeros are happening. It's looking like I've got one. Definitely looks like I should try negative 3. It looks like I should try the positive 1/2, and it looks like I should try the positive 1. And that would account for 3 of them. It looks like that's where they are. Let's see if those work. So again, we're looking at to see if negative 3, positive 1/2, and positive 1 work. So, if we set up our synthetic division, we use all of our coefficients. We don't have any zeros to fill in, so we just do 2 plus 3 minus 8 plus 3. And again, let's try one of those ones we were thinking. Let's start with negative 3. I would bring down the 2. I'd get 2 times negative 3. I'd get negative 6. Negative 3 times negative 3 is 9. I would get 1. 1 times negative 3. Oh, look at that. It's a 0. How cool. And what I can do now is I can kind of stop there, and I can write out this factor, and then factor the quadratic. That might be a little bit easier for me. So I'm going to write x minus 3 as a factor, so I'm going to say x plus 3. That would give me the 0 of negative 3. And then what I have here, I lost a degree because I started with a cubic, and so when I divided and got a 0, I don't have a quadratic. I'm going to have 2x squared minus 3x plus 1. Excuse me. And when I factor this, what I'm going to get is I'm going to get x plus 3 outside of (2x squared minus 2x minus x plus 1. And what I did there is I did that factoring that I've shown you guys in class, where I multiplied the 2 and the 1, and I got 2. And I asked myself what multiplies to be 2 and adds to be negative 3, and the two numbers are going to be negative 2 and negative 1. I multiply them, I get 2. I add them, I get negative 3. And then when I put those back into my quadratic, this is how I fill them in. I get 2x squared minus 2x minus x plus 1. Now I factor by grouping. And I get a 2x outside x minus 1. I take out a negative 1 here, and I get x minus 1. And so when I finish factoring, I get what's on the outside, 2x minus 1, and what's on the inside, x minus 1. And now, when I set these all equal to 0, I have a 0 at negative 3. I have a 0 at 1. I have a 0 at 1/2. And so just like it looked in my calculator, I do have zeros at those points, but it's important that we're able to prove things in more than one way, graphically and analytically. Alrighty. So, that is one example, again, of the rational zero test. We'll finish by approaching a broader question. So, if you're given even less information, if you just have x to the 5th plus x cubed plus 2x squared minus 12x plus 8, and you're asked to find all the zeros, a good strategy for you is to combine a bunch of what we already know. We know we can find all the possible zeros by doing the factors of the constant over the factors of the leading coefficient. And that would tell us all of the possible ones, but it's even more useful for us to do that and then look at our graph and then perform synthetic division. So that's how we're going to approach kind of all of these questions where they ask you to find all zeros. So that being said, what I'm going to do is I'm going to first find all of my possible zeros. And again, what I can do there is I can use the factors of the constant and divide by the factors of the leading coefficient. So the factors of 8 are going to be plus or minus 1, plus or minus 8. And the factors of the leading coefficient are just going to be plus or minus 1. So the possibles are going to be plus or minus 1 and plus or minus 8. Okay, so my possible zeros are 1 and 8, negative 1 or negative 8 as well. So what I'm going to do is I'm going to graph my polynomial. I'm going to graph x to the 5th plus x cubed plus 2x squared minus 12x plus 8. Excuse me. And so what it looks like is happening here is it looks like I've got some more zeros going on than I realized. It looks like I definitely have something going on at negative 2. So in order to get there, let's first take the possible zeros that we found. Let's use synthetic division with these. We know it would definitely be a good idea to start with 1, and then let's see what polynomials we're left with after that. We know that 1 would probably be a good idea to divide by, and it looks like 2 would also be a good idea to divide by. So let's pick those. Let's use synthetic division with both of those, and then let's get to a polynomial that will be a little bit easier to work with. And I also want to investigate about those 8s, and it looks like my graph isn't touching those. So let's instead just take a look at the positive 1 and this 2 for a second, and let's see what we have going on. So I'm going to start by setting up synthetic division. I'm going to have 1. And then notice that I'm missing a to the 4th power. So I'm going to have a plus 0, and then I'm going to have a 1. I'm going to have a 2, I'm going to have a minus 12, and then a plus 8. And now what I'm going to do is I'm going to bring down that 1. I'm going to say 1 times 1 is 1. 1 times 1 is 1. I get 2. 2 times 1 is 2. I'm going to get 4. 4 times 1 is 4. I'm going to get negative 12 plus 4 is going to be negative 8. Negative 8 times 1 is going to be 8. And I'm going to get a 0. Awesome. So I know that one of my factors so far, one of them is definitely going to be x minus 1. Awesome. Now let's use this shortened polynomial here, and let's see if that negative 2 that we were looking at is going to be helpful. So let's bring down a 1. We'll say 1 times negative 2 is going to be negative 2. We're going to get negative 1 times negative 2 is positive 2. We're going to get 4. 4 times negative 2 is going to be negative 8. I'm going to get negative 4 once more. Negative 4 times negative 2 is positive 8. And I'm going to get a 0. Awesome. So I know my other factor is also going to be x plus 2. So here's what I know that I have so far. I know that I have the factors of x minus 1, x plus 2, and now it started as a 5th power, then it was a 4th, and now it's to the 3rd. So what I have is x to the 3rd minus x squared plus 4x minus 4. That's what I found so far. And what we can keep doing here is we can divide what I'm going to have here is I'm going to have a repeated root. And here's why. Here's how I know that. If we go back to our original graph, take a look at what's happening at x minus 1, the factor of x minus 1, where our root is 1. At 1, our graph is touching the x-axis, so we know that that's a characteristic of a repeated root. That being said, I know it has to be repeated to an even power, so I know that I'm going to see x minus 1 as a factor at least 2 times. And I can prove that hypothesis by just performing the rational zeros theorem again with this shortened cubic polynomial. So if I were to find the rational zeros of this, what my possible answers would be negative plus or minus 4, plus or minus 2, and then plus or minus 1, all over plus or minus 1. And again, I know that those are my possible zeros, but I am interested in seeing if x minus 1 is the repeated root here. So what I'm going to do is I'm just going to test the minus 1 on the outside of this new shortened cubic. So I'm going to have 1, minus 1, plus 4, minus 4. I'm going to bring 1 down. I'm going to say 1 times negative 1 is negative 1. I'm going to get negative 2. Negative 2 times negative 1 is going to be 2. I'm going to get 6. And I made a mistake here because minus 1 is not the one I'm looking at. I'm supposed to be looking at positive 1. So let me just start over here real quick. We're looking at the root of positive 1. We want to see if this is going to be a repeated root. So let's start over. We would bring down 1, and we'd say 1 times 1 is positive 1. And then here I would get negative 1 plus 1, which would get me 0. There we go. Then if I had 0 times 1, I would get 0 again. And then 4 plus 0 would get me 4. And then 4 times 1 would get me 4. And here I would get 0. And now, since I know this is a repeated root, I know that my factors are going to be x minus 1, x plus 2, and then I know that x minus 1 fits in here, so I have x minus 1 as another factor because 1 was repeated twice. It touched the x-axis. And then I know I have this quadratic, x squared plus 4, where I don't have a b term, I just have a 0. Now, x squared plus 4, what that's going to end up being is imaginary, right? If I set x squared plus 4 equal to 0, then what I get is x squared equals negative 4. And I get x equals the square root of negative 4, x equals the square root of 4i, x equals plus or minus 2i. And so I take all of this information and I can write out all of the factors that I know exist for this polynomial. I know I have an x minus 1, an x plus 2, an x minus 1, and now I know that I also have a plus or a minus 2i. So I have x minus 2i and I have x plus 2i. Those are all of my factors. So I know that all of my zeros are going to be 1, negative 2, and then I'm going to have plus or minus 2i. Those are all of the zeros that are going to happen for this polynomial. So what you're going to be doing is just keep on using the rational zeros theorem, keep looking at your graphs to help you get started, finding which ones you should test, and again, use your knowledge of repeated roots in order to understand what might be happening. And that's all I have for you. We'll see you in class on Monday.